All right, so number 68 here in the Finney text. It's on page, looks like 330 or so. Second order differential equations, number C. This looks like it's actually, the textbook maybe is wrong here, so this is just plus 0, I believe. So let's just go over that. So if we have a second derivative given here, of course, d2y over dx2, or squared, or whatever you want. Okay, that's the second derivative. So let's take the integral of both sides here with respect to x, and we'll see what happens. So I get first derivative here, right? dy dx equals, well, the integral of e to the x is itself, and the integral of a minus x here would be a minus what? 1/2 x squared, okay, plus c. All right, so when we get to this point, what we want to do is we want to take a look at what kind of conditions I have. So the dy dx is 0 here. When x is 0, the derivative is 0. So I'm going to go ahead and put a 0 in here, and I'm going to put a 0 in for each x to solve for c. So 0 equals, what's e to the 0? Is that 0?
1.
Yeah, it's 1. Yeah. 1 minus 0 equals c. Plus c. So c equals, take this 1 over to the other side, c is negative 1. Got that? Okay. So now we have, over here, we'll start over here in blue, I have actually dy dx equals e to the x minus 1/2 x squared minus 1. Let's now keep going, because we need to find, again, we need to find the solution. Find the specific solution with these initial values. So we'll integrate again, right? With respect to x. Integrate again with respect to x. So this becomes just y now. That's excellent. The integral of e to the x, love that e, hey? Oh man. Integral of e to the x, e to the x. Love that. Minus, okay, so we need to up this 2 to 3. We also need to divide by 3 again. So it's 1 over 2 times 3. That's 1 over 6 x cubed. Minus, now this is going to be x, right? The integral of minus 1. And then we don't know, we have another constant here, which we generally keep as d, because this is not the same as a c. So let's do another constant there. All right, so we're getting close. This d here can be found because when x equals 0, the question also says that y equals 1. So I can go 1 equals e to the 0 minus 1 over 6, 0 cubed minus 0 plus d. So that is a, this is a 1, right? That's a 0, and this is 0. So subtract 1 from both sides. Those 1s are both gone. I get 0 equals d. Does that look right? So this is what I want to write as a final answer. The particular solution here in this second order differential equation would be y equals, and I'm going to go back to, this is the latest version that I have without the d, so now I can put the d in, and I have y equals e to the x minus 1/6 x cubed minus x, that would be a plus 0. So yeah, I don't know where they get the 1/6 from. I'm not sure. I think that in the book is wrong, so I think this is correct. Question?
No,
or observation?
question
Oh yeah, about something else? Okay, any questions about this one? Does that clear things up for you? Yeah? Okay. You're welcome.
So the integral of e to the power x is just e to the power x.
Say that again?
The integral of e to the x is just e to the x.
Yes. The integral of e to the x is simply e to the x. If this was a minus or something, we'd have a problem, right? But if it's just e to the x, the derivative of e to the x is e to the x. The integral of e to the x, therefore, would be e to the x as well.
Oh, yeah.
Remember? Because if you take the derivative of it, it's itself. So the integral of it would be itself as well.
That's right.
Yeah.
Because what about e to the 2x?
Well, e to the 2x then, if you were going to do this, e to the 2x, right, it would be itself still, but you'd have to divide by the derivative of this. So it would be 1/2 of that.
Oh.
Remember, divide by the derivative of the exponent there. Now, that makes sense because if I take the derivative of this, right, that's going to be 1/2 times e to the 2x. Yes, chain rule says I need to multiply by derivative of this, so times 2. So these cancel out, you get e to the 2x. So you do get this back if you take the derivative. So this would be the integral, right, of e to the 2x. Yeah. Yeah? All right, awesome. Okay. Okay, so if we take a look at this one, this is separable as well. You see we have a y here and an x over here. So we're going to have to separate those. The d of x, the dx can come up top. So we're going to have x plus 2 dx on one side. And then we're going to have to divide by y plus 5. So we have 1 over y plus 5 dy on the left side. Okay. So that's how that kind of separates. That's the first step, right? You got that? This is very similar to a question we did last class, I believe, because we're going to have to do logarithm here, right? Natural log to actually, when we do the integrals. So we'll integrate both sides. This one with respect to y, and this one with respect to x. So what's this going to be? This is going to be natural log y plus 5. Yeah, absolute value y plus 5. And there's no number in front of y or anything, so it's just that, right? The derivative of y is 1, so we don't have to divide by anything like that. So on the other side, we have 1/2 x squared plus 2x plus c. Okay, so this is just first order. This one is from the first order group of questions. So that's just a, well, that's not where the 1 goes, but there's not a second derivative, right? So we're already down to, we've got y here, so we don't have to take another integral. Just first order, one step. But what we do have to do now, before we solve for y, and I think I've mentioned this before, but I just want to stress this again. Do not solve for y before you solve for c, okay? So it's solve for c first, before you solve for y, right? Then solve for y. That's very important because it'll mess you up, totally mess you up. So initial conditions are x equals 0, y equals 1 here. So before we manipulate anything, solve for y, we got to get this c figured out. So I'm going to say ln of, what's y? Oh, 1. So it's 1 plus 5. And this is going to be 1/2, what's x? 0. It's going to be easy. Why do I keep doing that? Let's see. So that's 0, that's 0. So c is ln 6, right? Ln 6. And you can drop the absolute value signs because it's positive, so ln 6. All right, so now I go back to this step right here, and I put this c in right here. That goes right there. So let's change colors and move over here a little ways. So we'll go ln of y plus 5, absolute value there, equals 1/2 x squared plus 2x plus ln 6. All right. So now we have to get y all by itself. And liberating y from inside a logarithm, we change the logarithmic equation to what again? Yeah, exponential equation. Awesome. So this ln, remember, is the same as log base e. So going to the exponential form of this, you take the base of the log and you put exponent of whatever's on this side, so all of this, and then equals this right here. And that's how you get rid of the log, okay? So that becomes y plus 5, still absolute value technically, equals e to the power of 1/2 x squared plus 2x plus ln 6. Okay. All right. So what we need to do here now, okay, is we're going to do plus or minus here and get rid of these absolute value signs. And then we're going to subtract 5. Okay. All All right, so we have y equals either plus or minus e to the 1/2 x squared plus 2x plus ln 6 minus 5. Let me pause for a second. All right, so what we need to do then is it's because this answer looks a little different than what we're coming around to. It's because of this right here. When you add ln of 6, e to the power of ln 6, okay. So when you have a polynomial and you're adding terms in the polynomial, that can be changed into a different form like this. So e to the 1/2 x squared, or x squared over 2, times e to the 2x times e to the ln x. It's here that this right here, that actually equals 6. So you have 6 times these two things. And these two things can be written like this, or they can be written just like this, you see. So plus or minus 6 times e to the x squared over 2 plus 2x minus 5. That is how the solution, that's how they have their answer written here. And then of course we have to figure out if it's plus or minus. So we have a 0, 1 for a coordinate. Okay, so if we have some kind of e function here, right, it would only make, let's see, it would only make sense if this was a positive 6 to stretch it up, a positive 6, and then minus 5 would bring that whole thing down so that it went through 0, 1, you see. And you could put in 0 in for x and 1 in for y and figure out if the positive here makes them equal or if the negative here makes them equal. But because of each of these two ways I just mentioned, it's the positive 6. So that's where you get this as the answer, is the way they have it stated there. So let me know if that is a problem for you, if you have any questions about that. See if I can get that on one page for you. Okay, so first and second order differential equations there. That's just an example of each.